pretty easy for humans. You jump off a cliff and pull a parachute. Robots, a little bit more difficult, as we found out. We found some drone parachutes online from a couple different companies. We chose to go with Mars. In early development, we decided to use a full rover prototype with mounting plate and everything. Unfortunately, I had grabbed a 3D printed mounting plate and not an actual injection molded mounting plate, so it was a lot more brittle. The parachute opened wonderfully with the microbit, but whenever the parachute fully deployed and put resistance and drag on the rover, it unfortunately shattered the 3D printed mounting plate and the rover pummeled into the ground.
Oh, that's, yes, this is terrifying. Okay.
But it did, the parachute did,
The parachute did deploy.
it did deploy.
It did its job.
Turns out whenever we threw the rover off the roof, it was spinning a little bit too much and the microbit wasn't able to detect a free fall because of the centripetal acceleration. At that point, we needed to switch to a different sensing mechanism. Switched over to a Teensy, which is running an Arduino code base, and using the Teensy prop shield, which has a 9° of freedom IMU on it, so gyro, accel, and magnetometer. It also has a barometric pressure sensor, which is what we kind of decided to use in the final setup. As the item is falling, you can sense the density change as it is falling of the air that you're falling in and trigger off of that. Did all of our testing here in Boulder, throwing it off the roof and everything. Everything was looking great. Went out to Moab to do kind of our final test and shoot for the video. Lo and behold, the first test run didn't work.
Well, it blew out the bottom.
The rover went off the edge of the ramp and didn't deploy correctly and hit the ground pretty hard. But we were all amazed once we got down to the bottom and to the rover that the rover still drove. We got that kink worked out, a couple other little things, and we went on from there to have great success.